Let's graph the function negative 2 raised to the x. Well, recall that what the variable touches is the base. So our base is a positive 2. This negative sign is just going to make the whole graph go upside down. So if we make a little xy table, and since our x is up here in the exponent alone, 0 will go in the center of our list. We'll do a little bit smaller and a little bit larger. And we have negative 2 raised to the negative 2. Well, that's a negative 1 over 2 squared. And 1 over 2 squared negative is a negative 1/4. So at negative 2, we're negative 1/4, just below the x-axis. So if we have negative 2 raised to the negative 1, again that negative exponent is a reciprocal, it's negative 1 over 2 to the 1, which is negative 1/2. So at negative 1, we're negative 1/2. So if we try negative 2 raised to the 0 power, well, anything raised to the 0 power is 1, but there's a negative out in front, so that makes it negative 1. At 0, we're negative 1. So if we try our negative 2 raised to the 1 power, well, anything raised to the 1 power says it just is itself, which is negative 2. So at positive 1, we're negative 2. So as you can tell now, we've got another decreasing function. And putting in our last value from our table, 2 raised to the second power is 4, so our answer is negative 4. And then if we want to connect our graph, we have our exponential curve, and we have our asymptote. And our asymptote is again here at the x-axis, and that's because there's nothing added to this equation. And we can look at the domain and the range. Domain for all of our exponential functions will always be all real numbers. And our range. Our range is how high and how low the graph goes. The graph seems to be going low forever, which it really is. So that's a minus infinity. And how high it goes is to 0, but it doesn't quite get there. So we'll use a parenthesis.